In this video, I'm going to cover the differences in hypothesis tests or significance tests for means and proportions, looking at the state, plan, and do steps. So we're going to start with proportions. So we have a 1 proportion Z test, and we have a 2 proportion Z test. Those are the two tests that we covered for categorical variables so far. So for the state step, if we start there, for the hypotheses, for 1 proportion, it would be P equals the alternative P greater than, less than, or not equal to. For 2 proportion, it's going to be the difference in 2 proportions is equal to 0. And then for the alternative, the difference in the 2 proportions is greater than, less than, or not equal to 0. Here it's going to be some number. Okay, so you're using the parameter P, the true proportion of the population proportion. And then the plan step, this is going to look really familiar. CVS. It's going to be the random condition, the 10% condition, exactly the same as you did for confidence intervals. Exactly the same. Now, there's a slight tweak now for the shape. Because now we have a claim for the true proportion, what we're going to do is we're going to use that claim. So how that's going to look is this. I'm going to need to take n times p and n times 1 minus p and make sure they're at least 10 for the large counts condition. So same exact 3 conditions. Now, if you remember back to confidence intervals, this was p hat, the sample proportion. Well, now I have a claim for the real proportion, so I'm going to use that. Again, my advice, don't ever use symbols, just substitute in the numbers to be safe. Okay. For your 2 proportion Z interval, or I'm sorry, 2 proportion Z test, you're not going to have a claim for the overall proportion. So what we're going to do is you're going to have to check for each sample proportion for each group. Are these at least 10? And then for group 2, are they at least 10? So you're going to have 4 numbers there. 4 numbers there. Okay, so that's the plan step. And then again, no degrees of freedom anytime we use the normal distribution. So it would be conditions met to a 1 proportion Z test or conditions met to a 2 proportion Z test. That's it. All right, on to the do step. So now everything's going to go back to this formula sheet. And the benefit of this is they have a generic test statistic, just like they did for confidence interval. It's made up of 3 parts. The test statistic, whether it's Z equals or T equals, is the statistic minus the parameter divided by the standard error. So you'll notice 2 of these are exactly the same as a confidence interval, the statistic and the standard error. The parameter just comes from your null hypothesis, whatever that number is, or 0. So as I flip onto the back for proportions, my statistic is p hat minus the parameter, which is going to be p, whatever we're claiming that is, divided by the standard error. But you'll notice here, we're actually going to use the standard deviation because we have a claim for p. So this is going to be slightly different for the 1 proportion Z test. So this is going to be Z equals, the statistic is my sample proportion, minus, I'm just going to put P null, whatever that value is from the null hypothesis, whatever that number is. If you're claiming that 30% of people have brown eyes, then this would be 0.3. That would be your null hypothesis value. Divided by, since we have a claim for P, we're going to use that claimed value times 1 minus its complement divided by the sample size. So on the formula sheet, it's really this, the standard deviation, because we have a claimed value. They're not putting P naught or the 0 for the null hypothesis there. So just knowing that you're going to do that. If you have a claimed value, use it. Now, for two proportion z-test, this is where the formula sheet is going to be really beneficial, in my opinion. So we're going to take the statistic. Here it is, the difference in the sample proportions, minus the parameter, going back to the null hypothesis, 0. We're claiming there is no difference. Divided by, now the standard error. For confidence interval, we use this. We had two different values for the proportions. Now we're saying we assume the proportions are equal. Well, why are we making that assumption? That's our null hypothesis, that when we subtract them, we get 0, which means they're the same. So I'm going to use this formula. And this sample proportion combined comes from taking the number of successes in each group, adding those up and dividing them by the sample size from each group. All right. So the denominator, my standard error of the statistic, is going to be that formula, the combined proportion times its complement times 1 divided by the first sample size plus 1 divided by the second sample size, where this combined value is, like, say for group 1, say in group 1 you had 10 out of 30 people had brown eyes, and in group 2 in that random sample you had 12 out of 40. So the way I would calculate this is 10 plus 12 divided by 30 plus 40. And whatever that is, that number, that's what's going to go here and here. All right. So that's it for, what are we doing? Categorical. That's it for your categorical test, your one proportion z-test, your two proportion z-test. So let me transition to means. So we have three different types of tests here. We have the one sample t-test. We have the paired t-test, and we have the two sample t-test. So I'm gonna do the same exact thing. I'm gonna run through the state, the plan, and the do. So understanding these are quantitative. We're measuring a quantitative variable, either in one group or two groups, but one quantitative variable. So here goes. For the state step, for the one sample, if I make a little chart here, paired, and the two sample. For the one sample, the null hypothesis is going to be mu is equal to some number. The alternative, that mu is greater than, less than, or not equal to that number. Paired, this is where mu sub diff equals 0, the mean difference. And the alternative is that difference is greater than, less than, or not equal to 0. You'd have to explicitly state, like, the difference. Is it before minus after, standing minus sitting? You'd have to be explicit about that. And for a two sample, it's the difference in the true means. So mu1 minus mu2 equals 0, and the alternative greater than, less than, or not equal to 0. So they all involve mu. It's a quantitative variable, so we're looking for the true mean, and you can see the differences here. Okay, let's move on to the plan step. I'll continue on with this chart. So plan. Still with the CVS, still with the random. This is going to be the same exact thing as I said in the confidence interval video. If it's one sample, it's got to be a random sample. Paired has to be an experiment. Two sample could be random samples, independent random samples, or an experiment, so random assignment. 10% condition, same as confidence intervals. Sample size is less than 10% of the population size. If you have an experiment, you're not going to check the 10% condition, most likely, because you probably don't have a random sample. You probably have volunteers. Okay, that moves us on to the normal large sample condition. And this is going to be exactly the same as it was for confidence intervals. I'm trying to think if there's any differences. No, there's not. So I'm just going to put this up again. If it's a one sample test, you're just going to have one sample size that you're checking to see if it's greater than 30. If it's not, you're going to create a box plot of that one sample with degrees of freedom of the sample size -1. If it's a paired t-test, then you're going to have two different lists. You're going to create a list of the differences if your sample size is not at least 30, and then you're going to run one variable statistics on that list and do a box plot on list 3. If your sample sizes are at least 30 and you have at least 30 pairs, you're just going to check that one, the number of pairs is greater than or equal to 30. Two sample t-test, you're going to have two separate lists. You're going to need to create a box plot of list 1, list 2. Make sure anytime you're creating a box plot, you want no strong skewness or outliers. If your sample sizes are both at least 30, be explicit, list both of them, show that the central limit theorem applies, and then that's it. Then you can name the procedure. So that takes us through the plan step. So the plan step is exactly the same for confidence intervals and tests for quantitative data. So let's move on to the last part, the do step. And I'm going to go back to that formula sheet again, as you've seen me do time and time again. 1 paired 2. So 1 generic test statistic formula. Test statistic is a z-score or a t-score. Z equals t equals. So it's going to be the statistic minus the parameter divided by the standard error. Exactly the same format as it was for proportions. I'm just going to be on the middle section of the back page. 1 statistic, standard error of that. So for a 1 sample t-test, the test statistic is going to be t sub whatever the degrees of freedom are. The statistic is the sample mean minus the null, mu null. So that's the value from the null hypothesis. So going back, it's going to be some number here. And then for paired and 2 sample, it's going to be 0 in almost all instances, divided by the standard error of the statistic, which I have here, s divided by the square root of n. Okay, the sample mean and the sample standard deviation, they're either going to tell you those in summary statistics, or you're going to run one variable stats on list 1 to get those values. Paired, it's going to look really familiar. Same thing, except this is going to be the mean difference minus the null difference, which is in almost all instances 0 from the null hypothesis, divided by the standard deviation of the differences, or the square root of the sample size. As we talked about with the plan step, you're going to have a list of the differences, like list 3. To get the sample mean difference and the sample standard deviation of the differences, you're going to do one variable statistics on list 3. You don't need to run that to get the sample size. You'll know that. For a 2 sample t-test, so now going back to the formula sheet, the statistic, I'm looking at the difference between 2 means. So I'm going to have t sub however many degrees of freedom there are. It's going to be the difference in the sample means minus the null value, which in most instances is going to be 0, divided by the standard error. So I'm adding the variances, so the standard deviation squared for each group, divided by the respective sample size. So this is going to be the sample standard deviation from group 1 squared, divided by the sample size for group 1, sample standard deviation for group 2 squared, divided by the sample size for group 2. They're either going to give you the summary statistics and you can substitute those values in, or if they give you the raw data, in order to calculate the means and standard deviations, you're going to have to do one variable statistics on list 1 to get the mean. Where did my highlighter go? To get the mean from group 1 and the standard deviation for group 1. That's where that's going to come from. And this one that I'm going to put in pen a little bit more, To get the mean and standard deviation from group 2, you're going to run one variable statistics on list 2. So I hope these videos were really helpful. They're a little bit longer. Give me some feedback. I'll continue to make some videos as we learn some more of these tests and intervals.